Hello everyone, welcome to our channel. Today we'll continue the third part of our video. We'll be continuing today with the with our fourth question, which is write a solution strategy to find the greatest common divisor of two numbers. You can draw a flowchart from the same for the same. Okay, so uh, we'll be continuing with the question number D. So in the question, you have to find GCD of two numbers. Suppose, for example, A and B now. Okay, to find a GCD of two numbers in mathematically, it's suppose we could take an example. Like if we take A is equal to 2 or B is equal to 4. Okay, let's see it mathematically how we find GCD. Okay, so let's say A is equal to 2 and B is equal to 4. Okay, so the GCD, the greatest common divisor of these two number will be 2. Okay, so let's take another example. If A is equal to 7 or B is equal to 20, suppose 21. Okay, so among them 7 will be the your greatest common divisor. Okay, so let's say another example. A is equal to suppose somewhere between 7 and B is equal to 11. So there is no common like other than 1, so will be 1 only. So in this three examples, what we have found is that our the greatest common divisor is equal to the minimum number, or it is lower than the minimum number. It's not more than that. Okay, so we are not finding here that 3 is the greatest common divisor or something which is more than this number. Okay, so by this logic we can find some solutions. Okay, so let's say we can assume from here that GCD of ours of any number A and B, suppose we take any general numbers, in this case always less than or equal to the minimum of that same two numbers. Okay, so this logic is we have come up with. Okay, so by this logic we can conclude a flowchart. Let's see a flowchart of this. Okay, so let's start. First, as always, start. Okay, then after that we will need to read the our variables. Let say read A, B. Okay, let's see this. Okay, this one. So now after this, we will need to initialize our sequence. So let's say if we are doing like this. So after from this all this results from the previous logic, we have found that our number is always lies between 1 to the minimum of that two numbers. Okay, so minimum of A and B. So it always is in between these range, not less than 1 also. It's more than 1 or equal to 1, or it is equal to the minimum number and less than of that minimum number. Okay, so by this logic we can find that, let's say if we initialize the number by 1 and afterwards we will increase it. Okay, let's say this one. Then after that, let's take in condition, which is we have found that this GCD of ours, GCD of A or A and B is less than is equal to minimum. Okay, so minimum of A and B. Okay, so by this logic we can have a little bit of condition here, which is if I is less than equal to minimum of A and B. Okay, minimum of A and B. So one side yes and other side no. Okay, here after this the number will go in the next step, and here let's take another condition, which will be if that I, or what we have taken, that initialized number is divisible, divides A and B both. So let's take A divides by I, by I, and B divides by I. So if these two conditions are true, then we will move to the next step, or if it's not, then we will we'll go rotate this step. Okay, let's say next after that we will replace our new GCD. Okay, so I will be replaced, it will be GCD equal to I. Okay, so it will be replaced. Then after that we will increase our initialized value. So I will write I equal to I plus 1. Okay, after initialize, after after increasing the initialized value, then we will connect this one with this, which will make it as a loop. Okay, otherwise if it's not goes as planned, it will it will go here. This doesn't go as what we have planned for, and it will go here and it will be connected to this box. Okay, so if this one if this one happens, if we are out of options, like if we pass the minimum value, then after that what will happen, then it will print the last digit. Okay, so it will print the GCD. Okay, so it's an output. Okay, then after that end. Okay, so let's do a quick rough example here. Let's more color, say yellow one. Okay. So let's see. Suppose A we have taken 3. Suppose 2, A have taken 2 and 4. Suppose B is 2, B is 4 and A is 2. Okay, let's say A is 2 and B is 4. Then first we will initialize with 1. So we'll start dividing 1. We will check if our minimum, these two values, is less than I or not. Okay, so we are saying here it's not equal, but it is greater than I. Yeah, it is yes. Condition is ours too. Then we will move to this part. Here it will be divided. Okay, so divided by I. Yeah, is this happening? 2 is divisible by 1 and 4 is also divisible by 1. So yes, it will go replace our GCD with the current one plus increase 2. So here now our new initialized value is 2. So now I'll check 2 is with condition this one is minimum or not. Yes, it is correct. Again we'll go here. 2 will be divided by 2. Yes, correct. 2 will be divided by 4. Yes, it is also correct. We'll go move to this part. It will change. GCD is new GCD is our is 2. Okay, we will hold on to 2 for now. Then after that we will increase it. We'll increase here. Now it is 3. So 3 will go here. We'll check. Yeah, now I is equal to 3. Wait, now if we check here, 3 satisfies the minimum value. Okay, so 3 satisfies the minimum value, but here if we come up, so if this condition is true, now we have here 3, I is equal to 3, so it condition is true. But here you see I is not divisible. Your 3 cannot divide 2. 4 also cannot be divided by 2. So in that case we will move to this part. So after that you will go here and to this part and here directly. So now I value is our 4. Okay, so again our new value of I is 4. So 4 will check. Yeah, it is equal. Then if this okay, it is equal, then it will come here. It will check divides. No, 1 is not correct. A is not correct with it. B is going well with it, but okay, 1 is not correct. So it will go again. No, and here. So now our value is up to 5. So now what happens here, that we get set wrong condition, that our 5 is not satisfying this condition. So we'll move to no. So we will print GCD. Okay, so what we had GCD last time, it was 2. So last the value which is visited this processing box was 2. So the answer will be 2. Okay, so likewise if you use different examples, you will get different results. Okay, I hope you understand this. Okay, we will move to the next question. Okay, let's see the next question. What it says, that write a pseudocode for finding the summation of n given numbers. Draw a flowchart for the same. Okay, so what we have to do is that we have to find the sum of n numbers. Okay, how it works, you see. For example, if we take, if n is equal to 10. So what it's asking is that if we take 10 numbers, then what will be the sum of those particular numbers. Okay, it's a sequential number. Like for example, if we take 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So what will be the sum of these two numbers? So what we can see here is that it is increasing by 1 every time. Like here, one increase, one increase, one increase. So here we can establish an I is equal to I plus 1 this initialize method. Then after that, what we can do here, one thing out is that we take the previous value and double it. Like after increasing, we can write sum is equal to sum plus 1. Okay, increasing one after another. Okay, we can use this method to implement in this particular program. Okay, and we can put a condition where it hits this last digit, like the n digit, n number, then it will stop the loop. Okay, so then we can create a loop among this and we can get our result. Okay, so here two ideas comes up, which one is to print one number after another and one is which is to sum all these numbers. Okay, so let's see. Okay, so question number E, answer you see. Let's start. Then first of all, we will need our n. We'll read n. Okay, so we'll need to put how many numbers we need to sum. Okay, next we will need to process something which is initialize both sum and our initialize function. Okay, so this two. Okay, then after that we will need a condition where we will stop after if it is equal, if the after the loop number is equal to our this n. Okay, so we can put a condition where like if I is equal or less than n. So this condition we can put. When it is more than that, then it will terminate the loop. Okay, so condition if I is less than equal to n. Okay, it's capital N. Okay, like this. Then two part will be there. One will be no, one will be yes. Okay, so now what we will do is that we will use these two formulas, like sum is equal to sum plus I and I is equal to I plus 1. Okay, so every time I will increase and it will plus here. So then after that, what will happen? The sum will be also increased. Like it will become 1, then 1 plus 2, 3, 3 plus like that, like this. Okay, so if we put this formula, sum equal to sum plus I and I equal to I plus 1. Okay, in the process tab here. Okay, then we'll print sum, whatever the result will hold the sum, will print that and will end the process. Okay, so if it exceeds, okay, if it exceeds the value, then we'll simply print whatever the last value we had. Okay, and the loop itself will repeat. Okay, if the loop itself will repeat like this. Okay, check and it will repeat. Okay, let's see an example by this. Okay, so if we take n is equal to 5, okay, and initialized value of sum was first at 0. Okay, and formula is sum is equal to sum plus I. Okay, let's I was at first I plus 1. So initialize I with 1, what we get? We get 2, means I 1 plus 1 2. Okay, so now I is 2. At first sum was 0. Okay, so first it will do 0 plus 1 because I value was at first 1. Okay, so now sum was 1. Okay, so what it will do is that I value will be put here. after increasing the value of I, sum equal to sum plus I. So now I value is 2. So here sum is now 1. So 1 plus 2 is 3. Okay. Then after that, the new value of sum is 3. Okay. So after that, what will happen? I will increase itself again with I is equal to I plus 2. Now I was earlier I was 2. Then next I will be 3. So sum new value of sum is also 3. And it will be sum equal to new value of sum is 3 plus new value of I is also 3. Now it is 6. Okay. So this will continue up to 5, up to 5 times until and unless this will become, this condition becomes false. Up to that time it will repeat. Okay. So if we see mathematically, if 1 plus 2 plus 3 plus 4 plus 5, so what is the first what we get? 1. Okay, then I increase it itself, then it became 2, and 1 plus 3 is how much? 3. Okay, so now new value of sum was 3. So if we see it mathematically, it's 1 plus 2 plus 3 plus 4 plus 5. Okay, so first I value was also 1 and sum value was 0. So first sum, plus sum is equal to sum plus I became, so what it became? It became 1. Okay, then I increase itself and became 2, and new value of sum is 1. So 2 plus 1, now plus this, how much? 3. Okay, so new value of sum is 3. Now I is also increased to from 2 to 3. So if we plus this, then what is it? 6. Okay, so as we know here, we got 6. Then I increase it from your 3 to 4. So now 4 plus 6 is now 10. Okay, so then after that new value of sum is 10, and I increase it itself from 4 to 5. Then 10 plus 5, how much is 15? So the result will be 15. And when this conditions is, and its condition no more satisfies this condition, then the program will end and print the last sum input, output. So sum at last sum will be 50. So result will be 50. Okay, I hope you understand. Let's see the next question, which is write a solution strategy for arranging three numbers in ascending order of their values. Draw a flowchart for the same. Okay, so what we have to do is that we have three numbers like A, B, C. Let's say we have three numbers, so we have to arrange them according to their values. Okay, so one method we can apply here, that we can arrange them in a particular set. Okay, like for example A, B, C. Okay, so we can write more of them, like for example B, A, C. Okay, then C, A, B. And again we can write here, suppose A, C, B. Okay, like this we can go for it. Then we can apply this particular logic to the flowchart. Okay, let's see. Okay, let's start with it, and let's take these three variables, like, okay, read A, B, and C. Input. Next we'll put some conditions, like each condition will be the the arrangement we have earlier. Okay, like first of all, suppose if A greater than B, and we will use an operator which is AND operator. B is less than C. So here what we are saying, that B is lies between A and B. Okay, if this condition is true, if this arrangement is true, then it will print that ascending order of A, B, and C. Okay, if it's true, then it will print the ascending order of A, B, and C. If it's not true, then we will move to another condition, which is let's say if let's we can arrange another way, which is b a and operator and a and c. So if this condition is true, then same way, ascending order of b, a and c. Okay, so we'll follow up this sequence. Let's see here. Okay, let's put a connector here. Let's put a connector here. So next, if again one if we can see here, it's no one here. If let's take another arrangement. If C in A and your A and B, okay, if this one true, okay, if it's yes, then we can print another ascending order of C, A and B. C, A and B. Okay, this one we can print. If it's still not, it's no, then we can go for our last option, which will be printing ascending order of C, B and A. So this one what we have left with at last is this is the last possible way what we can get among three numbers of ascending order. Okay, so then after that we'll display it. Okay, so this display, or simply we can write print here. Okay, so we'll write here, write print ascending. Okay, and we'll end here. Okay, we will end here, and then after that what we will do is that we will connect all these. Okay, we'll connect this right here, and this one will go up page connector here. Here it will go. Okay, so like this. So if we see, and if you see from first with a rough example, that first it will check different in a sequence way. Okay, so if we see here, first the numbers. Okay, let's see. So A, B and C. If it's in this way, then it will print ascending order in A, B, C. Okay, if it's not, then it will go for B, A, C. Okay, let's see. This is B small. Okay, then if it's not this way, then again it will print C, A, B. Okay, still if we don't get this one, then we'll print C, B and A. Okay, so these four possible ways we can print. Okay, so this is just an example of how we can print three numbers in ascending order. Okay, we can use swap option also, but that is a little bit complicated. Okay, I hope you understand. If you if you go for an values, like if we see here, okay, if we take A is equal to 3 and B is 2 and C is 4. Okay, so A is not bigger. A is not bigger than A is bigger than B, but here this condition doesn't satisfy. Okay, if you consider this one, B, C, B, A and C. Okay, so if we check B is smaller than A, yes it is. B is smaller than A, correct? This one correct. A is smaller than C or what? A is smaller than C. Yes, A is also smaller than C, so then this condition will be the result. Okay, let's come to the next question. Next question is Z. So what we have to find is that we have to announce all the even numbers from a given set of numbers. Okay, among some numbers we have to find which one of them are the even numbers. Okay, so let's say if we have 5 numbers, so we have to find among them which one of them are even. Okay, so to find even numbers, there's a very simple method, is that we have to divide the number. If the remainder of that number is 0, then that number is a even number. If it's divided by 2 and the remainder is 0, then it is a even number. And if the number is divided by 2 and remainder is 1, that's a odd number. Okay, so we can distinguish among using this particular method. So for division, the a different operator has been used, which is this operator. This is called a modulation. Okay, so if a number is divided by this, usually we get the quotient as a answer, but in this particular way we get the remainder as our answer. So if it gives us a 0 as a remainder, that means it's an even number, and if it's 1, that means it's an odd number. So we'll follow this logic. Let's start. Okay, first of all we will need an input, how many numbers we need. Okay, so input n. Okay, next we need to initialize our series, so which is I is equal to 1. Okay, next we will put a condition here, which will be if I is greater than n, then 1 will be yes and 1 will be no. Okay, so in no section we will put again one condition here, which will be our this division modulus condition will be I module 2 equal 0. Okay, if this one is true, it's yes, and if it's no. Okay, so if it's no, then we will increase it, the initialized value, by 1, and we will continue with it. So if it's yes, then we will print the value of I. Okay, and if it's done, we will stop it at the end or end. Okay, so now what we will do is that we will connect this one here. Okay, here, and print I1 to here. Okay, and then we will make it as a loop. Okay, here it will go again, it will check if it's correct or not. Okay, let's see how it works. So first of all, suppose I was 1. Okay. So first I is equal to 1, then it will check 1 is, so first n you take n equal to 5. We'll take I as 1 and this 5. Okay, so condition is not correct, so it will go here. Then to formulate 1 module 2 equal 0 or not. So this also not okay. So again pass through, I will increase to 2. Okay, so now new value of I is 2. So what will happen? 2, we check 5, yeah, it's not true. We'll go to the next one. Here it will formulate 2 module 2 equal 0. Yes, it is, remainder is even. Okay, so this is true. So now what will do? It will print. Okay, again it will come here, again it will increase the value of I, and again it will go. So now our I value is 3. So again we'll check 3, then 5. Okay, this still condition is not true. Come here, we'll check I is 3 module 2 equal 0 or no, it is not, it is 1. So that is why again it will increase the value of I, again it will go here, again now I value is now 4, so 4 module 2 equal 0. Yeah, if this condition is true. Okay, so for 4 we'll check with 5. So this is not true. So we'll come here again to check here this one. Okay, so we'll get a again even number. It will print again. It will increase itself, and then it will continue with the next step, which is I is equal to 5. Here I 5. So this is also not true because it's we said greater than, not greater than, equal to. Okay, so until minus 5 will check, it will not sorry, it will not check, and after, so it will not check and will not continue the next. Okay, it is no, again here it cannot be done, so in that case it will break the loop. Okay, so when it okay, that's it. I hope you have understood. So this way we can identify numbers, even numbers among a particular set of numbers. Clear? Hope you have liked this video. Do like, share and subscribe. If you have any query, let us know in the comment section. If you want any other topics to be discussed like this, feel free to ask in our WhatsApp group. The WhatsApp group number will be in the description, and the previous videos about this particular chapter are linked to the description. Okay, feel free to watch them.